All right, everybody. So we got the circle equations to look at. Much easier than the stuff that we've been doing. Believe it or not, equations, they follow a pretty simple pattern, and we are just going to check that out. So as you're watching this video, you should open up Desmos.com and go to the graphing calculator function. And what I want you to do first is to type in each one of these equations and then make a quick sketch of what you see there. See if you can try to figure out where you think the radius or where the center is and what the radius of each one of those circles would be, and see if we can find the pattern so that you can figure out how to write the equation of a circle. So go ahead and pause now and go over to Desmos and try to type in those equations and see what they look like. All right, so I went ahead and did the first one here. I just pulled up Desmos on my phone and graphed it here. That you go, looks like the center is right about there. That's a little bit more than 2 above and below. About the same right there. So 2, 1 would be its center. And the radius then, it's kind of hard to tell. Sorry about that. I just realized I had something typed into the equation wrong. So the center, if you notice the circle's a little bigger now, right, is still right there at 2, 1. But then the radius would be 1, 2, 3, 4. Gets me right to that spot over there. So I have a radius of 4. If I try to sketch that from 2, 1 over 1, 2, 3, 4. And I can actually, since it's a radius on a circle, go in all 4 directions. 1, 2, 3, 4. 1, 2. And having that there kind of helps me sketch the general shape of the circle. Not perfectly, but a whole lot better than trying to freehand it. There we go. So if you haven't already, pause and try to finish those other 2 up, and I'm going to go ahead and put those in now. All right, so I went ahead and filled those last 2 in. Looked like the center here was at -3, 2. Radius I counted over was about 5. And this one was right on the origin, 0, 0. But the radius was a little funky. Here, I wanted to show you that it looks like it's clearly at 7, right, my radius. But when I zoomed in, look at that, it misses 7. Doesn't actually quite hit straight on it. And we're going to see why. Is that maybe you've picked up a pattern already, is that the radius is coming from that number that it's equal to. It's actually the square root of it each time. And if I try to square root 50, I don't exactly get 7. If you do the square root of 50, just over 7, which is why we're just a little bit past 7. So square root of 50 is actually our root. And this is exactly where all these numbers come into play, or where the equation comes from, is that whenever you want to graph a circle, you've got its center point that makes up most of the equation. Do you guys notice how the numbers you're getting here are the exact opposites of what's in there? The one with x, the opposite of that is your x value. The one with y, the opposite of that is your y value. So the way you would write that is x minus h, since h is the first number right here, and we square that, plus y minus k, square that, equals your radius squared. So that would be the general form of each of these. Whenever you want to graph a circle, you actually have x and y on the same side, adding and subtracting some number, being squared, added together, and equaling the radius squared. Right? It's kind of a complex setup, but circles are kind of a complex thing. They're very simple, but for a computer to graph them, one, they're not a function. They're not like straight lines or parabolas. They kind of lap back in on themselves, which is why we need such a weird formula in order to make them work. Right? So you won't have to do too much with this. Just understand how that formula kind of sets up. And then a lot of it's just interpreting things from there. So like here, when I ask where's the center and radius, well, as long as you know that the opposite of these numbers are your center, makes it real easy to do. Bang, like that. Give you a second if you want to think about the next one ahead of me. Where would the center of that point be? Negative 3 is 0 because there's nothing being added or subtracted with y. Just like how up here, they didn't have anything added or subtracted. That's why it was at 0, 0. But I could rewrite this x plus 0, y plus 0. It's still the same thing. For the radius, you just square root each of these numbers. So the radius would be equal to 6 here, and simply the square root of 12 right there. That actually does simplify, if anyone's curious, to 2 square root of 3. There's a 4 that's baked in here that you can square root. 12 breaks down into 4 and 3. If you square root the 4, you get 2. The 3 left over. Personally, I don't care which one you leave. Just, for those nerds out there. Just kidding. You're all nerds and I love you. That is the more precise technical answer, but I'll take square root of 12 as well. As long as you understand the idea that you're getting the radius by square rooting that. Maybe work ahead at this point. Pause and see if you can actually write the equation from the given information. So just reversing what I showed you right there. Go ahead and pause and see if you can do that now. Whoop, whoop. There it is. Make sure you're doing the opposites. So since it was a negative 1, I added 1. Since it's a positive 6, I subtracted 6. Both parentheses are squared and added together. Then you take your radius and square it for the other side. When you have the fraction over here, squaring a fraction just means squaring both numbers, the numerator and denominator. So you get 2 times 2 is 4, 3 times 3 is 9. And again, I did the opposites. These are both 2's because it's squared. Oh, pretty easy, right? Compared to the stuff you've been doing. This is walking the park. All right. But it does get a little more challenging. Not too bad, but a little bit. So here we go. We're going to write the equation, not just graph it. I put the graph there to help you visualize. But we're going to write the equation that is centered at 0, 0. Well, that's nice. I already know the first part then, x squared plus y squared. All I have to figure out is what the radius is. Okay, shouldn't be too hard. So goes through a point negative 3, 4. Negative 3, 4. All right, so I've got a circle that's like that. By the way, since it's negative 3, 4, kind of like what I did with the radiuses here, going in all 4 directions to help me graph, I can actually do that on this circle as well. Instead of going left 3 and up 4, I could go left 3 and down 4. That point will be on the circle because it'll have the same radius as this will. And right 3 up 4. Or right 3 down 4. If one of those points is on the circle, all of them will be. So that really helps give you a guide to kind of draw your circle around. Let's get a rough sketch. It's lumpy. Here we go. Anyways, the 4 points, don't need them. They just kind of help a little bit in sketching. What we need is to know how far this radius is, because radiuses don't go over and up. They go direct from the center to a point on the circle. But what we're going to do is we're going to use those coordinates to help us get that length. So since I went over 3 and up 4, well, I've basically got a Pythagorean theorem problem going on again. 3 and 4. If I do 3 squared plus 4 squared, 9 plus 16 gives me 25. Square root of that is a radius of 5. Actually, I don't care that radius is 5. What I'm interested in is, remember, it's radius squared. Oh, you can't see that. Radius is squared. Radius squared. So actually, I didn't even need to square root this. I could have just stopped at the 25 because that's the number I'm putting over here. It's not the radius. It equals the radius squared. So I found the radius is 5. 5 squared is 25. Maybe work ahead and see if you can do the next one. Similar idea. You've got the center, so you hopefully already know what to set up in your parentheses. It's all about finding the radius now, though. What is the radius so that we can finish the equation? So pause the video and see if you can work this one out. Hey, I didn't even draw the circle this time because I wasn't supposed to, or I didn't have to. Just asked me to find the equation. All I did is I plotted where the center was and where that point on the outside was, and I just looked at how far over and up. This time it was 2 and 3, so I did 2 squared plus 3 squared, which is 4 and 9. So 13 is that side squared. If I was doing the actual Pythagorean theorem, I'd have to square root that 13. But I'm not. I just want the radius squared, so I just use that 13 right there. That's all. I hope that makes sense. Maybe I should just to clarify, this is the 4, so Pythagorean theorem would equal your radius, right? That's the radius side. A squared plus B squared equals C squared. Leg squared, hypotenuse squared. So that's the 4, that's the 9, that's my R squared. That gives me 13 is the R squared is where that's coming from. Normally, you square root to find that length, but in the formula, we use R squared. R squared. So I don't really care to find out what R is. I needed the radius squared in order to finish my formula, which I got. I did the opposites. Got it. And finally, you're writing the equation just from a graph. So no information is given. For most of them, you can see the center. So that should make the first part easy. This is -3, -4. So it'd be x plus 3 squared, y plus 4. Because again, you do the opposite. So negative becomes positive. And then I need to find a point on the circle. Ooh, that's nice. When it's straight across like that, I can just count 1, 2, 3, 4, 5. Radius is 5. 5 squared is 25. So that's all there is to those. I don't know if you could see any of that. I wasn't under the camera. Poop. I found the location of the center so that I could set this part up is -3, -4. So I did +3, +4. They're both in parentheses squared. And then since it was straight across, I just counted 1, 2, 3, 4, 5. Radius is 5. You set it equal to the radius squared. So 5 squared is 25. Go ahead and pause. See if you can do the next one on your own. It's very, very similar. There you go. Center is right here. That is left 1, so I have a +1. And it's not up or down any, so I didn't do a +0. I just left it as y squared, kind of like what we had way back yonder. When it's not up or down, you don't need anything with your y. If it's not left or right, you don't need anything with the x. Here it's not up or down any, so I just left y squared. I did count out that it has a radius 1, 2, 3, 4. So 4 squared is 16. All right, the next one gets a little trickier because when we look at the up, down, left, right, almost did it again. How about I move the camera? There we go. Left, down, up, right. It's not hitting exactly on grid lines. So I'm going to have to use this point with the center, kind of like what we were doing up here. So I know the center is going to be right 2, down 5. So x minus 2, y plus 5. And then I have to find my radius doing rise and run Pythagorean theorem style. So here I've got a run of 2 and a rise of 1. So 2, 1, looking for r. 1 squared plus 2 squared equals r squared. 1 plus 4 equals r squared. R squared is 5. Not 25 because I didn't find the radius. I found the radius squared. The radius would actually be the square root of 5. But I don't want the radius. I want the radius squared. Bang. Bang, bang, bang. All right. Last one. I don't give you nothing. You get a circle on a graph. Figure out the equation. Woo! You don't even know where the center's at. Kind of looks like it's right here. But is it? Maybe it's a little above. Maybe it's a little below. Well, here's what you can do is you can find 3 places that the circle touches grid points. So we've got one right there, looks pretty darn close to, one right there, pretty close to, and I got 2 over here. I'll just pick this one. You only need 3. We've actually got 4 for the same reason I was showing you up there. Kind of you can use all the way around. We only need 3 though, because we just need to make a giant right triangle. And from that, it goes up to and over 6. Cut those in half, you find the midpoint. Whenever you do this, it will always make a diameter. So if we go halfway, that'll be the center. Like right here, if I would have went all the way down and over, that would have made a diameter. This works every single time. You have 3 points on a circle like this. If you can make a right triangle out of them, which on a grid, you're almost always going to be able to, halfway will get you straight to the center. So half of 2 is 1, half of 6 is 3, right there. So going from the point -3, 3, I'm going to go left 3, up 1. So that would be negative 6, 4 is my center. So there's my center, negative 6, 4. Now, to find what that radius actually is, I need to use those numbers again, 1 and 3, to find my radius, or better yet, my radius squared. So I've got radius squared equals that 1 squared there plus 3 squared there. Radius squared equals 1 plus 9. Oh, my radius squared is going to be a fat tenner. So I have x plus 6 plus y minus 4 equals el tenno. Senor Diaz. Found the equation of a circle with nothing but the circle given. I'm too good. Hopefully this isn't too hard. Much easier than the stuff that you had been doing. It all revolves around this basic setup of the equation of a circle. But if there is anything that's confusing, as always, I'm here for emails, questions, concerns, complaints, all the above. You know how to reach me. Let me know what you need.